Motor exerts a force of 20 time squared on the cable. So the cable is rolling in, and the force is increasing with t in seconds. Determine the speed of the 25 kilogram crate when t equals 4 seconds. The coefficients of static and kinetic friction between the crate and the plate are 0.3 and 0.25. So we'll do mv1 plus the integral of f dt equals mv2. It starts from rest, and so this is 0. So we're going to go from T1 to T2. The question is, we don't necessarily know what T1 is, because the force is 20t squared. So if t equals 0, the force is 0, and we haven't overcome our static friction. So there is a time when that's going to happen. So force equals 20t squared. The force of friction, the static friction, okay, is a 25 kilogram crate times 9.81. That's the normal force because there's nothing pulling up or down, so the mg is equal to the normal. And 0.3 is the coefficient of friction. So we get 73.6 is the force of static friction. So 20t is equal to 73.6, and t squared is equal to 1.92. So we're going to integrate from 1.92 to 4 seconds. So we'll integrate 1.92 to 4. T squared minus, so that's the force pulling that way, and the friction back is 25 times 9.81 times 0.25, the kinetic friction. So it's the same as this, except for it's the kinetic value instead of the static value. dt equals 25 v squared. So we put the values into there. So now we have 20 thirds t to the third minus 61.3 t from 1.92 to 4 equals 25 v2. And now we have 20 over 3, 4 cubed minus 61.3, 4 minus 20 over 3, 1.92 cubed minus 61.3, 1.92 equals 25 v squared. And solving v squared, or v2 is equal to 10.1 meters per second.